Hi, I'm going to solve here a few examples of how to find the domain of a function. I'm going to start with these cases, how I call it the simple roots. It's just a way to identify, a personal way to identify these cases like x minus 5 or x plus 9 or this one here. So basically, it's any case where you don't have any factors, anything multiplying within the root. That's why I'm calling here simple roots. Just a way to name it quickly, just to make it clear. Okay, so let's get to the first example here. This for f of x is the square root of x minus 5. And here you have to make sure that what's inside the root here has to be greater or equal than 0. Now I'm going to add positive 5 on both sides of the equation here in order to get to here. So x has to be greater or equal than 5. Now, in order to get the solution here, I'm going to use the classical method here of using a line here. This line goes from negative infinite to positive infinite. So basically you have to place this 5 somewhere in this line here. I'm going to place it here from 5. And as x is greater or equal than 5, that is to say that f of x will go from here to 5, from the 5 to infinite, positive infinite. Now, there's something else, because this greater or equal than 5 is telling you that you have to include this number 5 in the solution. So the way to represent that graphically would be just to use this, a color circle here, a full circle. So now the only thing left would be just to write it in the proper notation. So it will be domain. I'm going to use it like this: domain of f, small f as a sub-index. Domain of f are all the numbers from 5, positive 5. You use here the bracket in order to notice that you are including the 5, and then you go to infinite, positive infinite here. And that will be just it for the first example. Now, let's get to the second one here. This g of x is equal to the square root of x plus 9. So you have to make sure that what's here inside the root has to be greater or equal than 0. So I'm going to subtract positive 9 in both sides of the equation. In equation, in this case, I'm sorry. X greater or equal than negative 9. So now you have to place this negative 9 somewhere here in the line. I'm going to say, I don't know, here, negative 9 now. So x is greater or equal than negative 9, so you place it, it's saying you start from here, you go to all the way along to positive infinite. Now again, as this is a greater or equal than symbol, that is to say that you have to include the negative 9, so you have to use this whole circle here, full circle here. So now the only thing left would be just to write the proper notation. As you may notice, this example is pretty similar to the last one here. So this is to say that it goes to domain from negative 9 to positive infinite. Now notice again I'm using the bracket here because I'm including the 9, but because of this greater or equal symbol. Okay, let's get to the third example here. This is h of x is equal to the square root of 10 minus x. Now this is, again, we have to make sure that this, what's inside the root, has to be greater or equal than 0. Now this example just changed a bit because here the x is negative. So the way to solve it, I'm going to solve it the long way. I'm going to do like this. It will be negative x greater or equal than negative 10. I'm going to subtract it. I subtracted negative 10 on both sides of the equation here. Now here's the thing, you have to, in order to take away this negative symbol from the x, you have to, okay, multiply by negative 1 both sides of the equation, in equation, and you will get to something like this, x, and here you will have a 10, but now when you multiply by negative 1, you have to switch the symbol here. So it will be x lesser or equal than 10. So I'm going to place somewhere here in my line this 10. Just remember that now is a lesser or equal, this symbol here. That is to say that all the values here for x will be from here, from 10, but instead of going to the right to positive infinite, because this lesser or equal will go to the left. to negative infinite. And again, as this is a lesser or equal symbol, you will have to include it by coloring out this circle here. Now, so the final answer will be the domain of h. It's all the number from negative infinite to the 10, positive 10, including the 10 by using the bracket here. Now, let's move to the third example here. It will be this one here, y of x, I of x is equal to all this thing. Notice something, we have here 3 roots and they're adding up here. But so the thing to solve these kind of cases is that you will have to take to repeat this process, the same process for each of the roots first. So you have to start with this one and this one and this one, but luckily these 3 cases, these 3 roots are actually the examples we solved previously, F, G, and H. So we can pretty much, well, assume that the result will be just the same here for each of these independently, these 3 roots. So the domain for this root would be x greater or equal than 5. Now for this one, which is g of x, would be x greater or equal than negative 9. Now for the last one here, which is actually the same as h of x, it will be x lesser or equal than 10. Now here the thing, now here comes the thing, because now that you have these 3 inequalities, you have to place them all together in this line here below. I'm going to use actually the color for F, G, and H here to color them out. I'm going to start with this one, which is the same as f of x. I'm going to place, say, here my 5. And this one is saying that x has to go from 5 all the way along to positive infinite. And we have to include the 5 because it's a greater or equal symbol. Now, we're going to do the same with the second one, x greater or equal than negative 9, which is just the same as g of x. I'm going to place my negative 9 somewhere in here, negative 9. And in this case, we start from here and the x is greater or equal than negative 9. So that is to say, again, we have to move to the right to positive infinite here. Now the only one left will be the third one, which is just the same as h of x. So we are going to do pretty much the same we did here. We're going to draw from here, from 10. We start here, and as x here is lesser or equal than 10, we have to go from here, but to the other side, to negative infinite here. And again, here we have to include this 10. Oh, I forgot that we have to include as well here the negative 9 in here. Now here comes the thing, because the solution here will be where all the lines meet. I mean, where they all meet together, because they meet from here, 5, to here, the 10. So for all this interval, what's represented in here is that the way to understand this would be any number that you could input to this I of x, and this number, as long as it's from positive 5 to positive 10, the result will be a real number. In any other case, it won't happen. Let's say, for example, I take the number 7 here. If I take the number 7 and I substitute it in here, I will get a 7 minus 5, and I will get as a result the square root of 2, which is a positive number. It's a real number here. If I substitute the 7 here, I will get in this one here, 7 plus 9, and we get as a result a square root of 16, which will be 4. But the thing is, it's a real number. Now, if I would place here the 7, I would get as a result a 3, the square root of 3, which is as well a positive number inside, and that would say it's a real number. So everything works out just fine as long as you pick a number, any number in this interval from 5 to 10. But the thing is, if you pick any number outside of this interval, you will get an imaginary number. Let's say you pick, I don't know, let's, from here you pick something simple, 0 here. You pick 0 here, if you substitute it, for example, in here, you will get as a result the square root of 10, which is just works out fine because a positive number inside. Now, if you substitute it in here, you will get a positive 9 in here, inside the root, which is just okay. It doesn't have any problem. But if you substitute in here, you will get as a result the square root of -5. Here comes the thing, because in order to find the proper domain, you have to find the values where I of x is a real number. You will get a real number as a result. So that's why it's how this drawing lines and graph works out just nicely, because where they all meet, it's where would be actually the proper domain, which would be here between 5 and 10. So the last thing would be just to write this down with the notation. So it will be the domain of I is it will be from positive 5, this, to positive 10. In both cases, using the brackets, just to sign out that you are including both values. And by that would be all with this example. And we'll continue explaining some other cases, finding domain of functions. But so far, I hope this will be useful for you.